use and so on and so forth. But if you see compared to the fingerprint, definitely the hand geometry system will be having multiple fingers. So the chances of FAR and FRR will definitely reduce. No doubt about it. Now, as I mentioned, the processing, the image processing applications are the same. You're extracting the features, you are matching the features. So the same image processing application happens with respect to the hand. And there is the pre-processing text step, the feature extraction step, the matching step, and so on and so forth. So this is the same as the fingerprint. But the actual matching algorithm with respect to the hand recognition system is slightly different from the fingerprint system. Now, in the hand recognition system, we are generally having what is known as a different technique. We have what is known as the steps called binarization, border tracing. You are tracing the border of the hand. You are having some salient or vantage points detection, and then you have several measurements that are taken of these vantage points or salient points, and then we deploy these measurements into some distance matrix measurements. Now I will explain how it works. First, what we do is we have a image. The image is converted first from a color or an RGB scale into a gray scale. After the gray scale, it is filtered. Filtered in the sense that you don't want the patterns on the hand or the fingerprint or the ridges or the minutiae. We just want the contour of the hand. And this is the contour of the hand. So the filtering is there. You get the contour of the hand, and then you need to remove some sort of noise that is there. This is like some dirt in the hand. So for that you need a filtering. So a color image of a RGB image of a hand through the steps of binarization is first converted into grayscale. Then it is converted into this contour, and the contour is also again, it is cleaned up and filtered, and we get all the noise removed. Now this impression of the hand and the contour of the hand, there is a process known as the border tracing. We are tracing the border. Now it is similar to a technique. You are putting your hand on the table, and then you are taking a pen and you are actually drawing the hand contour. With the pen you just go on, same logic, but we use a computer and an algorithm known as the border tracing algorithm, whereby we are able to draw this impression or the contour of the hand. This is the next step in hand recognition. After this, what we do is we have point extraction. We look for vantage points or salient points. There is a standard set of salient points. This is a salient point. This is a salient point. This red is a salient point. This is a point. This is a point. This is a point. This is a point. So you have red points, you have gray points, and once you get these salient points or vantage points, you have a series of measurements made of these vantage points or salient points. And these measurements export into a feature vector. This feature vector will have the 5 lengths of the fingers. This is the length of the finger. 1, 2, 3, 4, 5. Then the 10 widths are there. There are width of the fingers is taken. The width is taken like this, and it is also taken here. So you have 5 lengths and 10 widths that are taken. And you see the measurement from P5 to this point is one measurement. E3 to V4 or this point is one width. This and this is another width. Like that you get 15 values in the feature vector. And these values are substituted into certain distance matrix vectors. And you substitute these values, like you might have heard about the Euclidean distance and all. You calculate these values of absolute distance metric, weighted absolute metric, and Euclidean distance metric based on this feature vector, which is nothing but 5 length and 10 width. For every finger there is 2 width. One width is from here to here, another width is from here to here. Another width, second finger, this is one width, this is another width. So there are 5 lengths and 10 widths that form what is known as a feature vector, and that feature vector is substituted and deployed into various metrics for the matching. So this is a simple logic of hand recognition system. I will explain again. First, you have binarization, where you convert the image, the color image, the RGB image into a grayscale. From a grayscale, you then convert it into a contour, and then you filter that contour for the black image of the contour. For all noise you remove. Then you trace the border of this black image. It's like you put the hand and you take a pen and you draw the thing. That is done by a computer, that is done by a system. The border tracing of the hand is taken. Then after border tracing is taken, certain salient points are identified. The salient points are this, like that. And then from these salient points, the length of all 5 fingers, the width, 2 widths are taken of each finger, and you get 15 different values which get into a feature vector, and this feature vector is substituted into various metrics, the absolute distance metric, weighted absolute metric, and Euclidean distance, and you get the hand recognition system. So it's a very it is of course similar to the it is very much similar to the system that is the what do you call the fingerprint system, but the only difference is that here we do not have a the minute. Instead of the minute, we have a feature vector with all those measurements. But the advantages, disadvantages are more or less the same as the fingerprint system. And obviously, when you have more than one, you have 5 fingers rather than 1 finger. Obviously, the FAR, the false accept rate, will be reduced. The false reject rate will also be reduced. It is, I think, fingerprint you can go up to 10, 5 to 10. In some cases, the FAR is 5, varies from 2 to 5. FRR varies from 5 to 20 and all in case of fingerprint. But in the case of the hand recognition system, I would think that the FAR, the false accept rate, is between 1 to 2. And the same with the FRR, or the false reject rate, is between 1 to 2. So that is all from today. Let me just take the attendance and stop the recording.